Okay, the 2013 external, question 1. Each year at Christmas, Jamie's grandmother gave him $5 plus $2 for each year of his life. So $5 plus $2 for each year, as shown in the table below. Let's fill in another couple just so we can see the pattern. 2, 2, 13, 15, and we could keep going. Write the equation for the amount A Jamie was given by his grandmother in terms of his age N. Well, I've sort of got it up here, but we can see that it's going to be a linear pattern, linear rule. It's a linear pattern which leads to a linear rule, and I can see that as the common difference is 2, that's what we times by each time. And obviously we've worked out already 1 times 2 is 2 plus 5. 2 2s are 4 plus 5. So to work out A, we're going to go 2 times the age, which is N, plus 5, or something equivalent to that. Right, part 2 says, find the amount Jamie was given by his grandmother at Christmas when he was 12. And you must show your use of the formula. So it would be 2 times 12 plus 5. 2 12s are 24, plus 5 is $29. Right, on the grid below, we're going to graph the amount of money that has been given. So first year he was given 7. Now let's check the scale. Yeah, it's going up in 2s. 2, 4, 6, 8, 10. So first year, 2, 4, 6, 7. Second year is 9. Third year is 11. Fourth year, 13. Now how far should we keep going? It doesn't say when to stop, so we've kept going there. So that's the age is along the x-axis and the amount he received is on the y-axis. Right, now there's a bit of reading involved in the next part. Jamie's sister Anna is 3 years younger than him. Each Christmas her grandmother also gave her $5 plus $2 for each year of Anna's life. In the grid, sketch the graph showing the total amount that their grandmother had given them each Christmas. And Anna is 3 years younger than him. So if we go back, oops, so I feel like I need a table. Jamie, Anna, and this is the total. So if Jamie is 3 years older than Anna, then when Jamie was 4, Anna was 1, and we could work out the total amount given. So Jamie would have got 5 times 4, 2 times 4 is 8, plus 5 is 13, and Anna would have got 2 times 1 is 2, plus 5 is 7, so altogether the grandmother would have given out $20. Jamie was 5, Anna would have been 2, so we could work out how much he was given. Remember the formula is 2n plus 5 for both of them. 2 5s are 10, 2 times 5 is 10, plus 5 is 15, plus 2 2 4 is 9, so that would have been 24. 6, 3, they would have got, you can see the pattern now, 28. So let's just check. On this grid, sketch the graph showing the total amount that their grandmother had given them each Christmas. So perhaps in a different colour. When Jamie was 4, she would have given a total of 20. When Jamie was 5, it was 24. When Jamie was 6, it was 28. And then we're off the graph. So we need to make sure that someone knows the blue equals the total. We might want to think about when Jamie was 3, Anna would have been 0, so it would just be Jamie's one, the 3 there. So that's the extra that they would have given. Right, let's try the next part of the question. This Christmas, Jamie and Anna received a total of $44 from their grandmother, so 2n plus 5, that's for Jamie's age, plus the amount that Anna got. Now she got 2 times, now her age is n minus 3 because she's 3 years younger than Jamie. So if you're using n for Jamie's age, Anna must be 3 years younger, and then we need to add 5 onto that. And altogether it came to 44. Right, so I've got 2n plus 5, plus now we need to do some expanding. 2n minus 6. So in algebra, we've got 4n, 5 and 5 is 10, minus 6 is 4, equals 44. 4n equals 40, and equals 10. So Jamie was 10 years old. We should write that down. Jamie was 10. And you can, of course, check it. So if Jamie was 10, the sister would have been 7. Jamie was 10, the sister was 7. 2 times 10 is 20, plus 5 is 25. And the sister would have got 7 2s are 14, plus 5 is 19. And altogether, that equals 44. Right, part 5, give the equation to calculate the total amount Jamie's grandmother had given him in n Christmases. Right, well I haven't got the table here, so if I just quickly copy it down again. This is the amount he was given by her, 7, 9, 11, 13, 15. Right, so now we want the total amount. So for 1 Christmas he got 7. After 2 Christmases he would have received 7 plus 9 is 16 in total. After 3 Christmases he would have received 7 plus 9 plus 11, which makes 27. After 4 Christmases in total, add on the 13 to get 40. Right, that should be enough. Now we're looking at the differences. Clearly the first differences are not the same, so it's not linear. We can look at the next one, which is the same, so it's quadratic. A quadratic pattern, which means we need a quadratic rule. So now if we go over to our calculator to work out a rule, we go into the stat menu and we'll put in the values from the table. And 7, 16, 27, 40. Right, hovering over F1. Now we need to make a decision. It's quadratic, which means we choose x squared. And across the bottom of the screen, of course, is the general form, so we start with that. Y equals ax squared plus bx plus c. I can see that a is 1, so that's 1x squared, we don't need to write the 1, plus 6x, and c is 0. And now we should change the lettering, so if we use t for total, instead of an x we'll use n for the number of Christmases. And t, we'll just let someone know t is the total. Right, and down to the last question. The equation of the graph below. So I can see that it goes through those x-intercepts, y equals x minus 3 for that x-intercept, and that goes through 0, so that's just an x, it's positive. We need to think about whether there's possibly a number in the front here. Perhaps another value. The other way to do it, of course, is to find 3 points that lie on your curve and to put them in the calculator. Right, so if we go back to our other method of using 3 points, I can see it goes through the point 0, 0, the point 3, 0, and if you look very closely, it's pretty clear it goes through the point 5, 5. You've got to be really careful of that. Make sure it goes through exactly. So back over to the calculator again, and we'll put our new point somewhere in stat, and I'm just going to delete all those numbers. Go across and we'll delete all of those. Exit out of that. Right, now we're ready. 0, 3, 5, 0, 0, 5, and hovering over F1, graph 1, calc. At this stage it's clearly a quadratic graph, a parabola, and you can see the general form there. Y equals ax squared plus bx plus c. And it tells me that a is 0.5, b is minus 1.5, and c is 0, so that will be fine. Coming over here, a bit more complicated if you're going to use this method, doing it by hand, you don't have to. Using that 0.55 and substituting the 0.55 into what we've got. So x and y, 5 equals, and I'm substituting a 5 where there's x. So we get 5 equals k times 5 minus 3 is 2 times 5 is 10. K equals 5 divided by 10, k equals a half. So for those of us that do it by hand, y would equal a half x minus 3, which would be exactly the same as what you've got over here.